All right, hello. This is going to be the second video. We're moving into the next homework, the one that's on volume of prisms. And so let's take a look here. It says, which of the following figures do you think are prisms? And name each prism. I mentioned in the last video that to make a prism you needed two bases that were congruent and parallel in space. So looking at this first shape, I see a base that's a pentagon, the top is a pentagon. Those pentagons look congruent to me and they look parallel. The only thing is the whole thing is slanty, but that's fine. This is still a prism. It's just one of them oblique prisms. Okay, now this thing sure as heck is not a prism, because the bases of prisms have to be polygons, meaning their sides have to be straight, and this thing has circles for its bases. So that's obviously a cylinder, that's not a prism. This thing's good to go. I see a hexagon on top. The bottom is another hexagon. Those hexagons are congruent and they are parallel, so that's a prism. Here I see a trapezoid in front and a trapezoid in the back. So the front and back are the bases. This thing's a prism. It's a trapezoidal prism. The bases don't always have to be the top and bottom. Sometimes the bases are the front and back, or the left and the right. That's pretty obviously a prism. This thing's a prism because the front and back, again, are going to be our bases. That rectangle on the bottom, that's not the base. The bases, there has to be two of them. And so this is a triangular prism. And this thing here, that's a pyramid, pretty obviously. So that ain't it. So four of these things were prisms. The other ones weren't. Now it does say name each prism. So I wrote down that this guy was oblique, but to fully name this guy, I better be saying it's an oblique pentagonal prism. This guy here is not oblique. It's straight up and down. That makes it a right prism. And because the base is a hexagon, it's a right hexagonal prism. Alright, what about this guy? I would say it's probably right. It depends what angle this thing forms. I assume it's a 90-degree angle, so I would call this a right trapezoidal prism. Okay, this guy, it's right. And it's probably a rectangular prism. Alright, and this guy is looks to me like it's right again, so it's another right. Now since the base is a triangle, it's a right triangular prism. And that's it. We named all the prisms. Alright, this thing says, what do all prisms have in common? And I told you before, to be a prism, you have to have two bases that are congruent and parallel polygons. I think that's it. I think that's what this question wants you to say. The only other thing that you could potentially say is picture a prism. So I mean, again, I need to duplicate this. I could take this polygon, I could drop it straight down, and if I dropped it straight down, then when I connect the corners, I'm creating a new face. See this face right here? We said that face right there was called a lateral face. And in the case of a right prism, one like this that stands up straight, y'all can see that all of those faces are rectangles because they've got the 90-degree angles. So all the lateral faces are rectangles. However, if I took two more of these here pentagons, and then if instead of going straight up to build a prism, I went sort of up and then over a smidge, then now when I go to connect my vertices, I get lateral faces here that are not rectangles anymore. Take a look at this one in the front. you can pretty clearly see that for this one in the front, I've got an acute angle here and an obtuse angle here. This lateral face is a parallelogram. So when it says what do all prisms have in common, you might mention that in addition to having two bases that are congruent in parallel polygons, they also have lateral faces that are rectangles. But that's only in right prisms. Or parallelograms. In oblique prisms. All right, there's a very complete answer to that question. Let's move on. So this thing says find the volume of each prism. Okay, fine. Again, there's some gray faces here that I don't love. I'm just going to take the gray away. For a rectangular prism, it's kind of important to know that literally any face here could be our base. Let's say you did pick this side over here on the right. Does it have another face that is congruent to it and parallel to it? Sure it does. So the left and right are congruent and parallel, so you could use them as your base if you wanted to. That would be just fine. If you did use these as your base, then your height dimension would be the 5, because the height is always the distance between them. Now on the other hand, you could let the front and back be the bases too. The front is this 5 by 8 rectangle. And there's another 5 by 8 rectangle right here in the back. So there's two congruent faces. If you chose to think of this as your base, then your height would be the 6, because the height is always the distance between those faces. Now again, all of that seems pretty silly, because I think most of the time, if you can get away with it, if you can let the bottom be the base, that's probably going to be the best idea. So let's let this bottom be our base. I'm going to do my trick again, where I want to be able to shade that face in so it stands out. Again, turn it a little bit dull. But yeah, if I'm treating that face there as my base, then my formula is going to work like this. We're going to write our formula, which is base times height. Every prism is base times height. But then what changes is, depending on the shape of your base, you'll get a different area formula. Now since our base is just a rectangle, we'll find the area by doing base times height. So simple formula. Our base, we said, is going to be this rectangle down here. That thing is 5 by 6. So we'll plug in 5 times 6. That'll give us the area of our base. Then you just multiply by how tall the prism is. So you plug in 8. And it looks like we're looking at a 30 times an 8. And that's nothing more than 240. 3 times 8 is 24. Yep. And they didn't give us units. So if you don't get units at all, then just say cubic units, UN cubed. But I do want you to say something. Don't just tell me it's 240 and that's it. Give me some units. And if the best you can do is to say cubic units, then go ahead. Alright, looking at this. It says the base of the right pentagonal prisms is congruent to the base of the oblique pentagonal prism. The area of each base is 32 square units, so find the volume of each prism. Okay, fine, whatever. They said the area of the base is 32. Well, don't we have a formula that says the volume is base times height? So they handed us the base. We don't need a formula to find the base area. They told us that it's 32. So you can literally just plug the 32 in for the B. Then we want to multiply by how tall we are, so you'll plug in the 4. And the volume of this right prism, at least, is just whatever 32 times 4 is. I still got my calculator up, so I may as well use it. Although I think I can do this one in my head. But 32 times 4, you just hit the buttons on your calculator, get what you get. It's 128. Hope that calculator wasn't in the way for any of this math. Nah, it wasn't. Okay. Alright, so 128. And if the area was just given in square units, then we'll give our units as cubic units for the volume. And what you're supposed to figure out from this problem is that the formula for an oblique prism is the same formula. We would still just say that the oblique prism is base times height, so it's still just going to be 32 times 4, which is still just going to be 128 cubic units. And that's it. Easy peasy. Alright, so 5. 5 is a little weird. I think this is sort of as tough as it ever gets. This is a trapezoidal prism. So one more time, just because I think it sort of helps to have this to look at, I'm going to trace out our base. This face here is our base. That's not so good. Okay, let me straighten that out. Alright, again I just want to use my trick. Let's get a little gray in there. And let's shade it down. So the idea again is, I know that this trapezoid represents our base. Why? Because it's the only thing there's two of. I've got one in the front, I've got one in the back. Nothing else is parallel. Just kidding, the top and bottom are parallel, but the top is small and the bottom is big. And so we didn't say that we just had to be parallel. We had to be parallel and congruent. You guys can see this trapezoid in the rear and this trapezoid in the front are congruent to each other. So that face is our base. Nothing else can be our base. So okay, now that we got that sorted, now we can do this problem. Let's go ahead and plug in. We know that our formula is always going to be that the volume equals the base times the height. Again, that capital B stands for the area of the base. So I don't know, let's make our base blue. And then I can fill in all these variables in blue. Since our base is a trapezoid, we need to do 1/2 times base 1 plus base 2 times height, and that'll be the area of our base, that alone. Then we still have to multiply by the height of the prism, and this all looks a little small. Make that bigger. Okay, so now we're substituting, and I told you before in a previous problem that the two parallel sides of the trapezoid, those are always going to be your bases. I like to think of the shorter one as B1, the longer one as B2. So in my volume formula, I've got the 1/2. Now the B1 and the B2 are 5 and 8. I can plug those in. The height of the prism, not the prism, the height of this trapezoid is going to be that straight up and down distance between the two bases. So it's here, which is 5. If we're given that dimension here as 5, then anywhere we go, that's 5, 5, 5, wherever you look. So in goes the 5. Now all I need is the height of the actual prism. And again, remember I said the height is the distance between these two trapezoidal bases. So as I slide this base back and forth, that dimension there that I'm rolling over, that's what capital H has to be. Okay? Or I could make a second one of these. And the height of the prism is however far apart those two trapezoids are. And I hope you can tell that distance for sure is the distance across that dimension. Or here, this corner to this corner. Or here, this corner to this corner. Or here, this corner to this corner. But either way, it's the 6.3. That dimension there is our height. Again, I don't care that it's not up and down. Not every height is up and down. This height is back and forth. But there's everything we need filled in. I'm not going to reach for my calculator right away. I'm going to do as much of this math as I can without a calculator. So the 1/2, maybe I'll leave alone. I'm supposed to do whatever's in parentheses first. So that's a 13. Then I got a 5. Then I got a 6.3. And so none of these numbers are even. If I took half of any of these numbers, it's going to come out to a decimal. And that's okay, but it's not easy to do. So I'm not going to try to do it in my head. So I guess I will go to my calculator at this point. How do I do that? I forget. Wrong one. Here we go. So let me clear out what I've got. I think I'm going to save the 1/2 for last. I'm going to start by doing 13 times 5. And then you want to hit equals. If you're using one of my 4-function calculators, then between every step, hit the equals button and see what you got. So 13 times 5 is 65. Now hit times again, 6.3. Actually hit the equals. Now I got 409, and now I want to divide that by 2. So I can either divide by 2, but with a half, you guys should also know you could multiply by 0.5, right? That's another way to do this. Hit equals, and I'm getting 204.75 as my answer. And remember, 2 decimal places is what I asked for. So if you have more than 2, round off to 2, but don't ever give me less than 2. And these are going to be cubic centimeters. So there's the answer for number 5. How's about 6? Alright, here's 6. So again, let's play another game of which of these faces is our base. It can't be the front rectangle, because that front isn't parallel to anybody. Can't be this small rectangle over here on the left, because that's not parallel to anybody. So this time, it is the bottom. The bottom is our base, and the bottom is this triangle. So again, I don't know why, I really like being able to see the base kind of shaded in. So I'm going to keep doing this. I think it helps. So I can lay the base in here. Needs to be a lot bigger. Okay, and again, it helps to be able to see the other one too, I think, because here's your prism. Those 2 bases define our prism. This also kind of helps as I move this one up and down. What dimension are we moving through? We're moving through this 4.1. That 4.1 is our height then, because that's the measurement telling us how far apart these 2 bases are. And of course you probably knew that was the height because it's straight up and down. When the height is straight up and down, it's pretty easy to see. But let's do this math. Alright, so how do we do this? We write our formula. We're always going to write the formula first. It's base times height. And again, if the base is the area, or if capital B is the area of the base, then capital B, we always have to plug in the appropriate formula. Now our base we said is a triangle. So the formula for the area of a triangle is 1/2 times base times height. So we need that 1/2. And then we need the height too. But at this point, now that our formula is fully done, we can start plugging in values. So the base of this triangle would be this side of the triangle, the 8.4. And the height of the triangle would be this dimension, the 2.4. Then we need the height of the actual prism, and as we said, the height of the prism would be the 4.1. And so if you're wondering what the heck's going on with these values, nothing. They're not part of our calculation, because we're going to get the area of the base using the 8.4 and the 2.4. We're going to get the height of the prism from here. So these numbers just aren't involved in the calculation, and they're not there like to throw you off or anything like that. You're supposed to know what numbers you need and pick the right numbers. Okay. Anyway, I can't do this math in my head really because these numbers are weird. I could at least maybe say that 1/2 of the 8.4, that's pretty obviously going to be 4.2. So I want to do 4.2 times 2.4 times 4.1. And let's see what that is. Okay, so clear everything out. We're going to go 4.2 times 2.4, hit equals, and then multiply that by 4.1 and see what we get. So 41.327 blah 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 blah. So this is a good opportunity to remind you that I want these things rounded off. So it's 41.3279999. Alright, so if I'm rounding to 2 decimal places, then you just look to the third place. If it's 5 or more, then you're rounding up. So we are clearly rounding up. So you better give me 41.33. And you better remember to tell me, not that it's meters, but that it's cubic meters. That's 6. We can do 7. Alright, 7's another trapezoidal prism. I'm still going to stick to my trick because I think it's somewhat helpful. So I'm going to highlight this here base. It's going to be this trapezoid. And then let me see if I can get that shaded for you. The reason I keep moving it to the side is because if I try to highlight this, it just highlights the whole picture. So that's no good, even if this was here. If I try to fill it in with color, it just fills in the whole picture. So let's drag this over. Let's make it a little see-through. Make it a little bit bigger. Hide the ugly corners. But there you go. I can copy this for you again. I can show you that, yep, there's another one exactly the same size back here. So we've got trapezoid in the front, trapezoid in the back. Those are definitely my bases. That again should help you visualize what the height of this figure is, because if the height is the distance between the two bases, that's clearly the 18. I can drag this back and forth. You can see the distance between them is given by that dimension right there, the 18. And by now you should be catching on to this, I hope. So this is going to be our capital H. This 8 is going to be one of our bases. That'll be our B1. The 6 that's back here, we could pull that here. That's going to be, well, actually this guy's our B2. Doesn't matter, but I always call B1 the short one and B2 the long one. And then of course this 6 will be the height. This 6 here is little lowercase h, because lowercase h is the height of the base, uppercase h is the height of the prism, but there's all the values we need. So let's just write our formula and get down to it. Volume is going to be area of the base times height. Since our base is a trapezoid, we're going to again have to use 1/2 times B1 plus B2 times height. Now again, that's just B. Remember, we still need the H. So yes, that's 2 H's. Little h, big H. Alright, let's plug in. Base 1 is the 6. Base 2 is this 8. The height is 6. And the height of the whole prism is 18. So we get a factor of 18 in there too. Alright, to do the math, you're doing the stuff in parentheses first, so that's a 14. Then depending on how slow you want to take this, we should be able to just put this whole thing in our calculator. In fact, if you've got a good calculator, let me show you what that might look like. So we'll take this calculator away. We'll bring back a better one. So if you've got a TI calculator, right? This guy. Then you for sure can just be plugging the whole expression in, right? Don't forget. So the 1/2, again, you could type in 1/2 as 0.5 times 14 times 6 times 18. It's pretty easy to just write the whole expression, click enter. So I'm hoping you guys are very comfortable with that. In fact, we could have just typed 0.5 times and done the 6 plus 8. You don't even have to do that. 6 plus 8, close parentheses. You don't even need multiplication signs even. You could just use the parentheses like I'm showing you in red. So 6, close parentheses, open. 18, close parentheses, mash enter. You're still getting 756 as your answer. Either way. So, click. Why is that still pink? So that tells us our final answer is the 756. With no units given, again, you'll just say units and put a 3 on it. And those are cubic units. And that's it. I hope that makes sense. Alright, I'm going to take this TI calculator away and bring my face back. I'm sure you guys love having that. There I am. Alright, so Maybe we're done. Nope, one more at least. Yeah, one more. Alright, so this is a good question. I'm pretty sure there's something like this on the quiz where you're not finding the volume anymore. You're trying to solve for this missing dimension, and they gave you the volume. So let's set this up and solve. Just like every other problem, we're going to say volume is base times height. But then our base is a rectangle, 9 by 7. So we'll do base times height to find the area of the rectangle, multiplied by the height of the prism. There's everything. So again, in this problem, we already know the volume. So you can even plug in for V. So you go 378. Then the base is 9 by 7. So that's B and that's H. And then big H is our variable. So to solve this problem, we use algebra. We'll multiply the 9 by 7 first. That'll be 63 times H equals 378. And then to solve this, you'll solve it like any other equation. You'll divide by this coefficient, which is 63. You'll do that on both sides. So the 63's cancel. And you find that your height is whatever this is. I don't know what it is. Let's bring back the little scientific calculator. That guy's easy to use. So on that, let's clear everything out. Let's do 378 divided by 63, and that's 6. Alright, so if all these dimensions are inches, then this 6 must also be inches. Again, remember, it's not a volume. It's just a height. It's just a linear dimension. So that would be plain old inches, not cubic inches, just plain old inches. But that's it for this one. So this was what? Prisms? You still have a homework covering cylinders next. So I'm about to make a video for that. After the cylinders one comes one that's about cones and pyramids together. And I'll make a video for that too. After that comes a video about spheres, because you've got a spheres homework too. And I'm realizing those perfect shapes I just drew are hidden behind this calculator. So let me get rid of it. Oh boy, what have I done? Cancel, cancel. Move that. There you go. That's what I was talking about. So there's still 3 more videos, 3 more shapes that you guys better understand. So cylinders, you can watch that video if you need to. Then there's cones and pyramids. You got to do that homework. You can watch the video if you want to. There's a spheres homework too. So let's move on to that. See ya.